Hi guys, I'm going to go over some of the homework from 193 today, just so you have some of the answers, not all of them, mainly the even ones. The odd ones, remember, you can check in the back of your book. Just real quick, number 2, basically they're asking you to find f of 7, g of 5, f of negative 5, and g of negative 3. All of these problems are very similar. They are giving you the x value. They're telling you that x is 7. They want you to find y. So in A, we're going to use f of 7. And basically, 7 is taking the place of x. So it's 3 times 7 minus 4. 3 times 7 is 21. Minus 4 is 17. So when x is the input, 7, y is the output, 17. B is similar. You plug G in. You plug 5 into the G formula in place of x. 5 squared is 25. 25 plus 2 is 27. That's going to be your answer to part B. In C, they want you to put negative 5 in. Negative 5 times 3 is negative 15. Negative 15 minus 4 is negative 19. In D, we're putting negative 3 in for x. That's going to be negative 3 squared plus 2. 9 plus 2 is 11. E is the first one where you have to work backwards. When they say f of x is 7, you want to actually replace f of x, the entire thing. We're not just replacing x. We're replacing f of x with 7. That's going to be set equal to the equation 3x minus 4. So we have to solve for x in this one. This is like telling you what y is, and you have to find x. You're going to add 4 to both sides to get 11 equals 3x. Dividing both sides by 3, we get 11 thirds, or 3 2/3 as your answer. Let's move on to number 4. Now, number 4 is a very involved problem. It took many students in class about 20 minutes just to do this one problem. Your final answer is the mathematician René Descartes. R-E-N-E D-E-S-C-A-R-T-E-S. He was one of the influential men back in the day who discovered geometry, or basically was a big player, so to speak, in the world of geometry. Now, in other fields of math as well. But here we have, in A, they're telling you what the x is, and you have to go in and find out what the corresponding y is. So when they say f of 13, we're going to go over on the graph where the input is 13. And then we're going to climb up the y scale to see what the corresponding y would be. Looks like we're right about there. If you travel over to the y's, it looks like that is 18. Since R is the 18th letter in the alphabet, that's why part A is R. Some of these are quite confusing, so if you had any trouble with any of these, I'm not going to do them on the video. I ask that you come to class tomorrow asking for a specific example. For example, if you got René Descartes, or if you didn't get this C right here, if you don't know why H is C, figure out which letters you messed up and which one you need to ask about tomorrow. Okay? Sounds like a deal. Let's go on to the next one. 5 and 6. These are all functions. The price of a graphing calculator and the sales tax you pay, the amount of money in your savings account and the time it's been in there. So I'm going to let's plop down a few axes here, a few L graphs. So for A, it's going to be the price of the calculator and the sales tax. The price would be down here. The tax would be dependent. The higher the price of the calculator, the more the tax would be. So that graph would look something like that. That is a function. B, the amount of money in your savings account and the time it's been in there. That's going to be time and the amount of money. As time goes on, let's say you make an initial deposit, your money should grow like that. That's going to be a function because for any given moment in time, you're not going to have two different amounts in your savings account. That's definitely a function. For every x, there's only one y. The amount your hair has grown since the time of your last haircut. From the time of your last haircut, your hair would be growing, so this would be the growth, and this would be the time. That's going to be a linear function, and it wouldn't grow two different amounts for any length of time. So this is a function as well. The amount of gas in your car's tank and how far you've driven. This is going to be your distance, and this is going to be the volume. And if you filled it up, it's going to decrease in a linear fashion. So this is another function. Those are the graphs 4, 5, and 6. Moving on to the next page. 7, check those in the back of the book, please. 8, I wanted to talk about the domain and range before I end the video. For domain, they're basically asking you for the farthest point left that this graph reaches for the x's, and then the farthest point to the right where this graph reaches. That's how you express the domain. Here's this red curve. It goes as far left as -6. That's like its western boundary, so to speak, if you were looking at a map. Its eastern boundary, how far to the right does it go, would be an x value of 5. Then here's how you describe the domain. The x's are smaller than or equal to 5, and bigger than, greater than, or equal to -6. That's the domain. For the range, instead of a left and right or west and east boundary, you're looking for how far down the graph goes, or how low it goes, or how far south it goes, versus how far up the graph reaches. So if you're thinking of a mountain here, how tall is this graph? What's the highest point that it reaches? It looks like our y values never go above 4. That's the upper point. And then the farthest down that it dips is right here on the eastern boundary. It looks like it never goes below -2. -2 would be your bottom out value. So the y's are greater than or equal to -2, less than or equal to 4. On the next page, we have, I definitely want to discuss number 10 tomorrow when you come into class. So let's table that one for tomorrow. Check to see in the back of the book some examples of number 9, and then also 12 and 13. I'm not going to do those on the video, but if you had any trouble with those, make sure that you ask me tomorrow. That concludes the quick 8-minute recap of the classwork from today. Make sure that you do the worksheet. If you didn't get a worksheet in class, it's a white worksheet, section 4.2 worksheet. There's a PDF attached to the class documents page on the wiki. Check that out. See you tomorrow.